Hey folks, how's it going? This is Mr. Murray coming to you with a Do Now for Course 2 Honors. Welcome to the fourth week of our COVID-19 closure. And this week we're going to kind of begin to put the finishing touches potentially on trigonometry. As the lesson notes from today indicate, I am going to be giving you a little electronic assessment sometime this week, either over the Otis platform, but probably more likely over the Google Forms. I'll have more specific information as the week progresses. What you need to know is that this assessment will not hurt you if you do poorly on it. It's not going to count against you. Don't worry. I just want to know where you're at so I can give you some feedback to help make sure you're in a good place with trigonometry. Okay, because I think we're at the point where if we were still in school, we'd probably be getting ready to wrap this unit up. If you think about it, remember in school, I was already talking about wrapping the unit up and preparing to give you a little assessment on it, and then we had the closure happen. So in this Do Now, what we're going to do is we're going to go back to what we know about special right triangles to kind of get us ready. This question's actually is going to be potentially familiar to you. I don't know if you're going to get the same numbers, but this is actually I took this from the first question of the mixed trig review assignment that I've assigned to you today. So in this Do Now, what we need to do is we need to find, we're given a triangle. We know that it's a right triangle based on angle ABC. We know that angle BAC or CAB, depending on how you want to call it, is 45 degrees. And what I want you to do is I want you to find the side length of AB and BC. Okay, so what I need you to do, pause the video, find those two side lengths, okay? And then when you're ready, unpause, and I'll show you what I got. All right. So here we go. So we know this is 45, this is 90. So if the triangle angles are going to add up to 180, which we know is true because of the triangle angle sum theorem, then this is 45. So therefore this is a 45, 45, 90 triangle. And remember, this is also true. This is called an isosceles right triangle. And that's because these angles are the same, and therefore the side lengths opposite the angles are also the same. Okay, because opposite of congruent angles is always congruent sides. So now that we know that in a 45, 45, 90 triangle, and that was actually a really terrible attempt to draw 45, 45, 90. And I apologize if there's any background noise. For whatever reason, my Mac computer decides that it's going to like to run loud on me. So this is 45, 45, and 90. We know that the side lengths are x, x, and x root 2. So what that means is that 18 is equal to x times the square root of 2. Okay? And I apologize for that notification. So in any case, 18 is your x root 2. Okay? So basically, I need to now figure out what's x. So if I can figure out x, I'm basically good. That's essentially akin to solving the problem. So a couple ways you could do this. You could divide both sides by root 2 and clean it up. Or you could square both. So a couple ways you could do it. So what I'm going to do is I'm going to divide both sides by the root of 2. That'll cancel. So x is equal to 18 over root 2. Okay, and then I want to rationalize its denominator by multiplying top and bottom by root 2. So what I get is x equals 18 root 2, and then these become a 2, and then these will cancel such that this is equal to 9 root 2. So the side length of AB is 9 root 2. The side length of BC is 9 root 2. Here's another way you could look at it. Because this is x and this is x, you know that x squared plus x squared equals 18 squared because of the Pythagorean theorem. So 2x squared equals 18 squared. Okay, so if I square root both sides, what I get is I get essentially x root 2, because when you square root, that becomes root 2 and that becomes an x, and the square root of 18 squared is 18. And remember, you don't do the plus or minus because in this case, you can't have a negative side length. So based on the context, you throw that out, and then you see it turns right into this problem right here, so that if you actually didn't know entirely how to solve it, the Pythagorean theorem would also give you some guidance. So what we have is 9 root 2 and 9 root 2. Again, just to show you, if we check our answers, okay? So if we check our answers, what I know is that 18 times 18, I'm just doing this real quick on my calculator. So 18 squared is equal to 324. So if I do 9 root 2 squared plus 9 root 2 squared, okay, so the 9 squared becomes 81, and the square root of 2 becomes root 2. This becomes 81 times 2, and 81 times 2 is 162. So you get 162 plus 162, which is 324. So you know you've got it. All right, so hopefully you're able to get this right. If not, I recommend you go back. This is on the Binder website, and if you don't have your notes available to you, or Google or something like that, this is a pretty well-known idea. And make sure you understand the two types of special rights. Okay, I think we also talked about it in the Hangout last week, so it'll be in the notes and video there too. Remember the 45, 45, 90, and also remember the 30, 60, 90. Okay, where you have x, x root 3, and 2x. Keep up the good work. Don't forget to love math, and have a wonderful day.